All right, so we are on page 14 and we're going to finally get into the Welch t-test. So the biggest problem with using the student's t-test is, in practice, is that third assumption that we talked about. So that third assumption, it assumes that both groups have the same standard deviation. And unfortunately, this is rarely true in real life. So if two samples don't have the same means, why should we expect them to have the same standard deviation? There's really no reason to expect this assumption to be true. And so in this section on the Welch t-test, we are going to talk about a variation on the student t-test that does not have the assumption of equal variance. So the assumptions of this Welch test, the Welch t-test, are very similar to those made by the student t-test, except for that the Welch test does not assume the homogeneity of your variance. So this leaves only the assumption of normality and the assumption of independence. The specifics of these assumptions are the same for the Welch test as for the student test. So the Welch test is very similar to the student test. For example, the t-statistic that we use in the Welch test is calculated in pretty much the same exact way as we calculated the student t-test. That is, we take the difference between the sample means and then we divide it by an estimate of the standard error of the difference. So we can reference the really complicated by hand calculation on page 14. The main difference is that the standard error calculations are different. So if the two populations have different standard deviations, then it would be completely nonsensical to try to calculate a pooled standard deviation estimate because you're averaging apples and oranges. But you can still estimate the standard error of the difference between your sample means. It just ends up looking different. So we can again reference the second equation on page 14. It's looking pretty complicated to have to do 33 of those by hand. So we'll use the software. Now, the reason why it's calculated this way is beyond the scope of this introduction. But what matters for our purposes is that the t-statistic that comes out of the Welch t-test, it's actually somewhat different to the one that comes from the student t-test. The second difference between the Welch and the student test is that the degrees of freedom are calculated in very different ways. So in the Welch test, the degrees of freedom doesn't have to be a whole number anymore, and it doesn't correspond all that closely to the number of data points minus the number of constraints, which is the heuristic that we've been using up to this point. So the degrees of freedom are in fact the third equation at the bottom of page 14, which is pretty complicated. So it doesn't really matter for the purposes of this introduction, but what matters is that you'll see that the degrees of freedom value that pops out of your Welch test tends to be a little bit smaller than the one that is used with the student test. And it also doesn't have to be a whole number. So let's move on to page 15 and let's see for the data set that they're using in this chart. I think they are just adding on to the Harpo data set. So let me double check. Yeah, the student t-test result was 2.115 So if we also check the Welch test, we will get that second row. So the Welch t-statistic is 2.034. The degrees of freedom, as we were talking about, is less. So the student test degrees of freedom was 31. The degrees of freedom with the Welch test is 23.02. The p-value for the Welch test makes it statistically insignificant, which is very interesting. The mean difference is calculated as the same value. The SE difference is slightly different, and the upper and lower bounds of our 95% confidence interval, those are slightly different as well. So let's keep going on page 15. So we just added the option to do the Welch test. And again, it was very easy. It's pretty much identical to when we did the student t-test, so it was really fast. Again, we just went under tests and we checked Welch. And then we already went over the output, but we can do it again. So we already noted that our p-value is no longer significant when we're running the Welch test, which is very important. And so as a general rule, it's not a good idea to go out of your way to try to interpret or explain the difference between a p-value of 0.049 and a p-value of 0.051, but what does matter is that you take a little bit of care and thinking about which test that you should use. So the student test and the Welch test, they have different strengths and weaknesses. So if the two populations really do have equal variances, then the student test is slightly more powerful, and you would get a lower type 2 error rate than if you ran the Welch test. However, if your two populations do not have equal variances, then the assumptions of the student test are violated, and then you're not actually able to trust it. So then you would end up, if you used it, with a higher type 1 error rate. So that would be your trade-off. So in real life, we tend to prefer using the Welch test because almost no one actually believes that the population variances would ever be identical. And additionally, we're just going to point out that while the student t-test is the default test in this software, in other statistical applications, like when using SPSS, the Welch test is the default. So we're going to take a break here, and then we're going to get into the paired means t-test next.